Section 7.2.51-T. The time required for an automotive center to complete an oil change service on an automobile approximately falls in normal distribution with a mean of 21 minutes and a standard deviation of 5 minutes. The automotive center guarantees customers that the service will take no longer than 23 minutes. If it does take longer, the customer will receive the service for half price. What percent of customers receive the service for half price? Well, first and foremost, let's go ahead and draw our bell curve and what this actually means. Okay, so if we draw our bell curve, okay, we know that the mean is 21 minutes. Okay, and it's telling us here that it won't take no longer than 23 minutes. But if it does, then they're going to receive half price for the service. So that means we want to find what is the probability here. Okay, so in order to do that, then what we can do is, one way is using the TI-84. If we use the TI-84, then in order to find the probability where x is greater than or equal to 23, well, that's going to equal normal CDF. The lower bound is 23. The upper bound is 9999. We know that our mean is 21 and the standard deviation is 5. So let's go ahead and put that in our calculator. So we have second distribution normal CDF. The lower bound is 23. The upper bound is 999. We know our mean is 21 and our standard deviation is 5. And so let's go ahead and copy that. Okay, so that gives us 0.3446. Okay, and if we multiply it by 100%, then that changes this to 34.46%. So what that means is that the percent of customers that receive the service for half price is 34.46%. Okay, now, again, we're using technology, so if we want to use StatCrunch, then what we would do is we would come in here using our normal distribution here. We know that our mean is 21 minutes. We know that our standard deviation is 5 minutes. Okay, and then we know that we want to find the percentage that's greater than 23, so we need to change our inequality to be greater than, and then we got to put in the number 23. Okay, so when we hit compute, okay, then we can see that we get the following. So again, that gives us the same number that we got here, which gives us 34.46%. Okay, next, part B. It says, if the automotive center does not want to give the discount to more than 4% of its customers, how long should it make the guaranteed time limit? Okay, so again, we want to draw the normal curve so we know that what we're talking about here. So again, here's our normal curve, right? We know that our mean is at 21, okay? And so again, it says here, if the automotive center does not want to give a discount to more than 4% of its customers, how long will it make the guaranteed time limit? So that means we're looking for the value of x here. And so we're looking for the value of x. And then the area is what's given here. And that area is 4%, which is equal to 0.04. Okay, so if we want to be able to use and find x, we want to use the TI-84. So if we're looking for x, okay, recall that that's going to be INV norm. Okay, and so we're looking for all of this area that's to the left here. right? And that area is 1 minus 0.04. So we can either use 1 minus 0.04 or 0.96 for our area. So we can put in 0.96 if we want, or 1 minus 0.04. We know that our mean is 21 and our standard deviation is 5. So let's go ahead and put that into our calculator. Second distribution, INV norm. We know that our area is 0.96. We know that 21 represents our mean, 5 represents our standard deviation. So let's go ahead and copy that. So here we get 29.75. So we can round that to approximately 30. And so therefore, we can say that the guaranteed time limit should be 30 minutes. Okay, and so how would we do this using StatCrunch? Well, again, we need to draw our picture first. Okay, so after we draw our picture, then we can go ahead and then plug this in. So we know that our mean is 21. We know our standard deviation is 5. And we know that the area to the left of x is 1 minus 0.04 or 0.96. And we know that this is less than because we want to make sure it's to the left. So 0.96 and then hit compute, and then we get 29.7 there. So let's go ahead and copy the picture of that. And then you can see that the value that we get for x here, okay, gives us approximately 30. And that's what we get for our result.